What if I told you the universe might already be dead, and we're living in its afterimage? Not tomorrow, not in a billion years, right now. Because when scientists ran the numbers on how the cosmos ends, they found something that shouldn't still be happening. You and me, thinking, breathing, inside a system that behaves like a body that hasn't realized it stopped moving. And by the end of this video, you'll know why some physicists say the universe ends not with a bang, but with a slow, merciless fade, and why we might already be inside it. But warning, once you understand what that implies for your memories, your choices, your future, you can't unknow it. This affects you more than you think, because the death we're talking about isn't one final explosion. It's a chain reaction that steals meaning piece by piece. Stars go dark, matter dissolves, time itself stretches thin. And this isn't fringe theory. The evidence comes from precise observations of ancient light, data showing our cosmos is drifting toward heat death, accelerated expansion, and maybe something worse. It began in 1998. Two rival teams were studying dying stars, Type 1A supernovae, because those explosions act like standard candles, the cleanest rulers for measuring cosmic distance. They expected to find the universe slowing down. Instead, the light was too faint, too far. Space itself was speeding up, pulled by something invisible, now called dark energy. That discovery later won the Nobel Prize and changed the ending of everything. We used to imagine gravity would someday win, collapsing all matter in a grand finale. But with acceleration, the opposite happens. Galaxies drift apart forever. New stars become rare. Old ones die. The sky thins to black. Energy spreads out until there's no useful difference between anywhere and anywhere else. No gradients to power life, thought, or change. That is heat death. Maximum entropy. The final cold exhale of reality. But heat death might not be the only ending. There's another possibility, a theoretical one that still haunts physicists: vacuum decay. Imagine the laws of physics, the forces, the masses of particles, balanced in a false vacuum, like a ball resting in a shallow valley instead of the deepest one. Quantum tunneling could kick that ball into a lower valley. If that happens anywhere, a bubble of true vacuum forms and expands at nearly the speed of light, rewriting the rulebook as it goes. Chemistry, gone. Atoms, unstable. Everything we know, unmade instantly. This isn't science fiction. The equations allow it. If a decay bubble had already formed billions of light years away, it would be rushing toward us now. We wouldn't see it coming. We wouldn't feel fear. There would be no last words. And if such a bubble formed anywhere in our past light cone, we're already gone. We just haven't reached that page in spacetime yet. The universe might already be dead. Causality just hasn't delivered the news. The most detailed snapshot of the infant universe, the Planck satellite's map of the cosmic microwave background, shows tiny ripples in the oldest light we can see. That pattern fits a cosmos dominated by dark energy, one that expands faster and faster. The same map that tells us where we came from also sketches the outline of how we fade. Count how many times you blink in the next 10 seconds. Each blink is older light reaching you from a younger sky. You are literally watching a universe grow colder while you sit still. Even if vacuum decay never happens, time is not on matter's side. Protons, the building blocks of your body, might eventually decay over unimaginable timescales. Experiments like Super Kamiokande in Japan have been watching for decades and haven't seen it yet. meaning protons last at least 10 decillion years. If they do decay, everything solid will someday dissolve into radiation. If they don't, black holes take over, swallowing what remains, then slowly evaporating through Hawking radiation, drizzling entropy into the dark until nothing is left but thin, cold noise. Picture a star field. Now remove one star every second. Keep going for 1 trillion years. That's what cosmic exhaustion looks like. Supermassive black holes already hide most of the universe's entropy, which means the graveyard is fuller than we thought. The universe isn't dying quietly. It's already half gone. Imagine being there. The last night, the last sunrise. Galaxies that once filled your telescope have vanished, red-shifted beyond visibility, like ships swallowed by fog. You can't even send a message to them anymore. Expansion stretches space faster than your words can cross it. Your sky becomes a shrinking island of light surrounded by an ocean of nothing. Relativity says we never see now everywhere at once. When you look into deep space, you're watching the universe's childhood projected onto the present. The cosmic microwave background is a baby photo burned into the walls of time, still arriving, still bright, with a world that no longer exists. So what do we mean by already dead? If the future is heat death and the past survives as light, then the present is just a thin afterimage stitched from ghosts. Every choice you make gives off a little heat. Your laptop warms your palms. Your heartbeat moves energy from order to disorder. That's not poetry. That's physics. You are participating in the ending. And yet, your mind is a local reversal, a temporary pocket of order in a sea of decay. You carve structure from chaos. For a while, that's beautiful and terrifying. If vacuum decay ever happens, it ends instantly. No pain, no warning, just a new set of laws replacing the old. If it never does, then heat death wins instead, slowly, silently, for eternity. Either way, the universe's ending is already determined. We simply can't stand outside time to see which page we're on. Imagine time as a stopwatch that never stops, until the numbers fade to static. That's the story physics tells so far. Scientists call the distant eras the degenerate age, the black hole era, the dark era. In human terms, it's simpler. First less light, then less life, then less anything. All of this follows from the same rules that explain your phone, your breath, your heartbeat, the second law of thermodynamics, the data from supernovae, and the shape of the cosmic background. Different instruments, same verdict. Touch your wrist. Feel the pulse. That rhythm is heat moving from order to disorder. You are an arrow pointing forward through decay. You might ask, if the end is set, why fear it? Because the timeline hides two knives, one slow, one sudden, and no one knows which is already in motion. Super Kamiokande hasn't seen protons decay, but not seeing isn't the same as never. The Planck data fits a dark energy-driven future, but no one knows what dark energy actually is. And if we live in a false vacuum, the trigger doesn't ask permission. All this physics only matters when you realize what it says about you. You exist in the narrow window where stars are common, chemistry is rich, and minds can wonder about their own impermanence. You ride an impossibly thin wave after the violent beginning, before the silent end. That makes every ordinary moment obscene in its rarity. You are alive during the brief era when the universe can remember itself. An accelerating cosmos means isolation. Eventually, every galaxy becomes its own island, cut off by expansion, unable to share warnings or wisdom. If there are others out there, we'll never know. Not because they died, but because the horizon erased the bridge between us. Picture a lighthouse turning across a black ocean. The beam moves. The fog doesn't lift. If vacuum decay is real, the universe might already be dead in the one way that matters. The ending is determined and on its way. If it never happens, then in a slower sense, it's dead anyway. A fade so complete that not even memory will remain. Either way, what we call now is simply the light that hasn't dimmed yet. The corpse is still twitching because a few signals are left to fire. That's us. We live on a thin ledge between beginnings we can't revisit and endings we can't escape. Every time you learn, love, or make something beautiful, you're briefly winning against the direction of time. Dread and wonder are just the same emotion, seen from opposite sides. The realization that you exist in a universe vast enough to end and small enough to notice you. If you want more of this, real science told like a mystery you can feel, subscribe. I post weekly. Come back and bring that uneasy curiosity with you. It's the only compass that works in the dark. But there's one question scientists still can't answer, and it haunts me. If vacuum decay is possible and eternity is long, a bubble should have formed somewhere by now. So why hasn't it reached us? Are we impossibly lucky? Or are we already hearing the footsteps and just can't tell which direction they're coming from?